All right, guys, here we go. Here we go. All right, guys, focus, 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 focus. An equation involving a derivative is called a differential equation. The order of a differential equation is the order of the highest derivative involved in the equation. We're going to be dealing with primarily first order. We'll let your Diffie-Q class talk about homogeneous second order equations, damped, undamped systems, all that good stuff. So this is just at the beginning, right? The intro. We're just scratching the iceberg here. Is that a saying? Scratching the iceberg or tip of the iceberg? All right. Yeah. Here we go, guys. Here we go. So this is what you're used to. You've done plenty of these. They're not too extreme. Those are pretty basic, right? So they're telling you what the derivative is. The dy dx is secant squared x plus 2x plus 5. And it says find all functions of y. You've done this many times. So this is y equals, and you're just doing antiderivative. Antiderivative of secant squared is tan x. Antiderivative of 2x is x squared. Antiderivative of 5 is, and then you write plus c for some constant c. And those are the ones that we've been doing all this time for some constant c. If you don't put the plus c, it's wrong, right? Because it says find all functions. And they all differ by some constant. Don't worry, next time we'll do slope fields and all that good stuff. But we're just starting out, guys. We're not going to do all this packet if you're thinking like, oh my God, we're going to do all this today. No, this is over 2 days. All right. Solve an initial value problem. Relax. You've done this already. So find a particular solution to the equation dy dx equals e to the x minus 6x squared whose graph passes through the point 1, 0. That 1 is an x. That 0 is a y, right? So you're just going to say, okay, antiderivative. Antiderivative of e to the x is just e to the x. Antiderivative of 6x squared is, let's see, add 1 to the 2, so that's 3. Divide by 3. 6 divided by 3 is 2, so 2x cubed. Let me know if you guys have any questions. Plus c. And then we just plug in our initial value, guys. That's a 1, that's a 0. So that's a y value. So 0 equals e to the 1 minus 2 times 1 cubed plus c. Get the c by itself. So I'm going to move e to the left and this to the left. So c equals 2 minus e. So what is my equation? My specific equation is e to the x minus 2x cubed plus 2 minus e. If I take the derivative of this, yes, I do get e to the x minus 6x squared. And there it is. That's it, guys. Cool or not cool? Okay. So here's where the differential equations that you're probably going to see on a free response come out. These are called separable differential equations. Look, a differential equation in the form of dy dx is f of y times g of x is called separable. We separate the variables by writing in the form, blah, blah, blah. The solution found by answer differentiating each side with respect to its thusly isolated variable. Okay, chop. What does that mean? Group the y's with the y's, the x's with the x's. That's all it means. So when you have something like this, so I'm going to go slow, guys. It says solving by separation of variables. Solve for y of dy dx equals. So the first thing I'm going to do, law of exponents. I'm going to go dy dx equals x squared y squared. Are we okay with that first step? Next step, I'm going to divide by y squared and I'm going to multiply by dx. So I'm going to write it like this. Dy, how should I write it? I'll write it right for now like this. Dy over y squared equals x squared dx. Do you guys see what we did? All right, now that we have, this is a y, it just came out kind of like what? All right, now that we have it like this, I'm going to go ahead and move this up to make it easier to take an antidifferentiation, to take an antiderivative. I'm going to integrate. And then you're going to say, okay, well, let's see, antiderivative. Y to the negative 2, add 1, divide. So negative 1 over y. And you can, if you want, okay, don't write this down because write it down. Plus C1 equals, antiderivative of the right-hand side, x cubed over 3 plus C2. All right, this is probably the only time you'll ever see me do that. You see how this is a constant? This is a constant. If I go minus C1 and I go minus C1, isn't C2 minus C1 just some constant? So sometimes some professors will write C3. I've never been a fan of that. We're just going to leave it like this, and we're going to let the situation tell us what that constant is going to be. So if you want to be a robot, just put the C with the X's. Chop, I don't understand what's going on. C2 minus C1 is just some constant, guys. You don't have to be doing this over and over again. Write a constant subset of 1, subset of 2, subset of 3. We'll let this situation tell us what that constant is. So what do? I know when y equals 1, x is 1. Do you guys see that? So I'm going to sub x equals 1, comma, y equals 1. So negative 1 equals 1 to the third power over 3 plus c. Move this 1/3 to the left. Negative 1 minus 1/3 equals c. So let's see, 3/4. So negative 4/3 is c. We're still okay? So I'm going to write this expression again, this one right here. I'm going to go negative 1 over y equals x cubed over 3 minus 4/3. I'm just doing algebra now. Man, do I have space? Okay, I'm going to write at my top of my margin here, but hopefully you have more space than yours. 1 over y equals x cubed minus 4 over 3. I just combined because they had the same denominator, 3 and 3. I'm going to move that negative. So I'm just going to, let's see, what am I going to do? Times negative 1 times. So here's what I have. 1 over y equals 4 minus x cubed over 3. Child, why'd you do that? I like to have the positive one in the front. So because sometimes the negative floats and it looks like the whole expression is negative. And then, okay, I'll stop. I want y equals, I have a fraction on the left, I have a fraction on the right. I can just go, choo. So y equals 3 over 4 minus x cubed. And there it is. How do we feel? Ask me, Salali. Ask me. All right. Don't worry. We're not going to do the whole thing, guys. We're probably going to stop right here on this one. Let me see. What's the next one? Yeah. All right. So here we go. So you can already see what UH quiz is going to come next. If you want to get ahead of it, I don't have a due date just yet. All right. Use integration to find the general solution to the differential equation dy dx equals 4x times x minus 1. So for this one, guys, go ahead and distribute. You don't want to use, any special. Dy dx equals 4x squared minus 4x. Okay. Antiderivative. We're not doing anything fancy here. If you want, multiply by dx, you can, but there's no two variables on this one. So I'm just going to go y equals 4x cubed over 3 minus 4x2 divided by 2, so 2x squared plus c. I don't see any issues, so let's just look for that. It looks like it's letter A, unless I messed up. Nope, that looks like it's it. And that's it. What do you guys think? Not bad, right? Okay. Example 5. This time, what is different about example 5, guys? I have a what in there. I have a y in my dy dx. Do you guys see that? So this one, here's how you do it. This is how you do it in the free response. I guess it doesn't matter in the multiple choice, but in the free response, guys, it has to look like this or you're not going to get a point. You're not going to get the point. Get the y's with the y's, the x's with the x's. So you're going to multiply by y plus 5. Whatever you do to one side, you do to the other. And you're going to multiply by dx and dx. So here it is. It's going to look like this. Y plus 5 dy. If you don't want to put the parentheses, that's fine. It's understandable. X minus 3 dx. Are we still okay? All right, next. What's my next move? Well, I want to get rid of that dy and dx. Integrate. So now you're going to have y squared over 2 plus 5y equals, Chav, where's the c? I'm going to put the c with the x, guys. X squared over 2 minus 3x plus c. So get it to here. Notice all my answer choices do not have a fraction. I'm going to put a giant parenthesis on all this, and I'm going to multiply it by 2. So here we go, guys. Y squared plus 10y equals x squared minus 6x plus, don't write 2c. How come I didn't write 2c? A constant times 2 is still a constant. Just write plus c. A constant times 2 is still a constant. Make sure that we understand that, guys. All right, next move. Let's see, what's my next move? I guess my next move, guys, is move these to the left, and then we'll see if we have to change polarities or not. So here's my answer. So I see negative x squared plus y squared. Let's see, what do they have next? So x plus 6x, and let me know if I'm writing it wrong, plus 10y equals c. So I'm going to look for that first. Negative x squared plus y squared plus 6x. Oh, what happened to the 10y there? Out. Out. Negative x squared plus y squared plus 6x plus 10y equals c. There it is. Sometimes you have to change the polarities again one more time, but we didn't have to do it that time. We still okay, guys? All right. Here we go, guys. Here we go. Guys, focus. All right. Divide, guys. Divide by secant y times by dx. So here we go. We're going to have, let's see, dy over secant y equals 1 over x minus 3 squared dx. Does everyone know how we got here? Oh, what do you mean? We want all the y's together, all the x's together. All right. No, I guess. These are separable differential equations, guys. The y's with the y's, the x's with the x's. That's what we said over here. Look. All right, guys, focus. Okay. Next move, guys, we should know a little bit of pre-cal. 1 divided by secant y is the same thing as cosine y. I hope that we are at the level at the moment. Hope by now we've done like at least, hundreds and hundreds and hundreds of antiderivatives by hand. Hopefully. Integrate. So here's what I have. I have sine y equals, and hopefully we've done enough. Look, this is a squared, x minus 3 squared. You don't need to do u sub unless you really want to. Negative 1 over x minus 3 plus c. Yeah, you guys have done a lot of antiderivatives. Hopefully by now we know it's like negative 1 over x squared, right? Add 1, divide. Okay, I'll show you guys. All right. I don't think this is one of those that requires u sub, but if you wanted to, u equals x minus 3, du equals dx. So then this turns into 1 over u squared du. So that's the same thing as u to the negative 2, antiderivative, add 1, divide by that number, negative 1 over u. So negative 1 over u plus c. So there it is, negative 1 over x minus 3 plus c. But by now, some of these should be starting to turn out into automatic, guys. If they're not automatic, that means that you haven't done enough. You're not prepared enough. You need to do more. So please make sure you do the antiderivatives by hand whenever possible. All right, so there it is. And let's just look for this answer. So there it is. All right, here's what you're doing today. Did they give it to me? Okay, they don't. Here's what you're doing today, guys. We do have a delta. Okay. All right, guys, focus. Given the differential equation, dy dx equals 2x minus 5 over y, find the particular solution, y equals f of x, with the initial condition f of 4 equals 2. All right, this is the same thing as just saying 4 comma 2. Multiply by y, multiply by dx. So here's what you're going to have. Y dy equals 2x minus 5 dx. You don't have to put the parentheses, but if you're one of those, it's like, oh, I need to have it. That's fine. Put the parentheses. The dx just indicates that's the end, right? When you're going to do the antiderivative. All right, here we go. Integrate, integrate. So you're going to have y squared over 2 equals 2x squared divided by 2, so that's x squared, minus 5x plus c. It depends on where you want to use your initial condition. I like to just use it immediately. That's just my habit. I'm going to plug in the 4, 2 immediately. So the 4 is an x, the 2 is a y. So 2 squared over 2 equals 4 squared minus 5 times 4 plus c. Are we still okay, guys? All right. 2 squared is 4. 4 divided by 2 is 2. Or I guess you could just cancel, right? So 2 equals 4 squared is 16. 5 times 4 is 20. Haven't done anything crazy, guys. 16 minus 20 is negative 4. So when you move that to the other side, c is 6. Let me know if everything checks out. Plus 4 plus 4. From there, guys, plug in the c right there. Y squared over 2 equals x squared minus 5x plus 6. You're just doing algebra, guys. This is why your algebra is important. Times 2 times 2. So we can get rid of that 2 in the bottom there, right? So you're going to have y squared equals, that's times 2, not that to the power 2. 2x squared minus 10x plus 12. Then Then I got to take a what? Square root, square root. Usually it's plus minus, but luckily our y value was positive. So y equals the square root. I guess I'll put it plus minus. 2x squared minus 10x plus 12, so we can have a good habit. Bless you, whoever sneezed. And you're going to circle the positive one. Why the positive one? Because when x is 4, the output better be positive 2. So let's see if it works. I'm going to put check. So square root 2 times 4 squared minus 10 times 4 plus 12. Let's see. 4 squared is 16. 16 times 2 is 32. I'm just checking. 32, 10 times 4. Is that a 4? 10 times 4 is 40 plus 12. So negative 8 plus 12 is 4, and the square root of 4 is 2. It works. When x is 4, y value is 2. It works. This is your equation right there. Okay. One last one. Yeah, if your algebra is weak, it's possible you can have a lot of trouble with this, guys. I put the solution at the bottom left-hand corner because the answer is going to look weird. Look how ugly this answer is. It doesn't have to look like that. That's just the answer. That's just the generic answer that Delta had. So let's see if we get that generic answer there. I'm going to go slow, guys. You guys ready? I'm going to go slow. dy dx equals e to the x plus 2 times 2 minus y squared with initial condition y of negative 2 equals negative 2. You guys ready? Here we go. The x's with the x's, the y's with the y's. dy over, I have to divide by 2 minus y squared. 2 minus y, close it, squared, equals e to the x plus 2, dx. Have I confused anyone? Here we go. I'm a little scared right here. What happened, miss? I divided by 2 minus y squared, so you have to put it in the bottom. See? It's yeah, I gotta divide by 2 minus y squared, divide by 2 minus, so it stays, it's like gonna go on the bottom. And this is like this over 1, you want to call it that. Times dx, so dx plus 2 times dx. All right. Here we go, guys. Here we go. I'm going to go slow. Integrate. And I'm going to go as slow as I can. So this will be 1 over 2 minus y. In reality, and I'm going to go slow, guys. Let me tell you what I just did. Okay, focus. I added 1. Remember, think about this as u substitution. So that would have been to the negative 2. Negative 2 plus 1 is negative 1. So 2 minus y to the negative 1 divided by negative 1. But look, chain rule, there's a negative in front of the y. So negative times a negative is a... Do we see how we got it? Okay. Or do you want me to do u sub so you guys can see it? Okay, let me do u sub here on the side. All right, guys, look, you got it. Focus, guys. I'm doing u sub here on the side. U equals 2 minus y. Du equals negative dy. Yeah, the derivative of y with respect to y is 1, right? So if I rewrite it, integral 1 over, I'm doing it with respect to, so I need a negative. Negative on the outside, u to the 2, du. Do you guys see what I did? And then look, so that negative is that negative, u to the negative 2 du. Negative, that negative is that negative, u to the negative 1 divided by negative 1 plus c. So negative times a negative is a positive. Add 1, divide by the number. Add 1. Antiderivatives. Okay. All right, here we go. Equals e to the x plus 2 plus c. Antiderivative of e to the x is e to the x. So antiderivative of e to the x plus 2 is e to the x plus 2. I'm going to plug in this. Maybe they're being nice. Negative 2, negative 2. I'm going to plug it in. 1 over 2 minus negative 2 equals e to the negative 2 plus c. I'm slowing down, guys. I'm going as slow as I can. 1 over minus a negative, so that's you're going to add them up. Fourth equals e to the 0. E to the 0 is, it's not 0, 1 plus c. So I'm going to move that to the left. 1/4 minus 1 equals c. So 1/4 minus 1 is a negative 3/4. And now slow down. Okay. This number, plug it in right there. Hopefully there are no mistakes. 1 over 2 minus y equals e to the x plus 2 minus 3/4. We can go so many different ways. I'm going to take a hint by looking at the answer choices. Oh, okay. They did it. They were lame. I would have thought they would have done common denominator. All right, you guys ready? I was about to go 4 over 4 to make one fraction, but looking at the answer, they didn't even bother doing that. So this is like saying that over 1. Yeah, I actually don't like their answer at all, but that's fine. You guys ready? Okay, I don't like their answer because it looks ugly to me. Instead of writing 4 over 4, you could have done a common denominator there, but this is like something over 1, and this is 1 over 2 minus y, so that means I can, there's an equal sign in the middle, so that means I can flip them both, and there would still be equivalent. Does that make sense to you? Yeah, a over b equals c over d, you can flip them. B over a equals d over c. All right, so here it is. So I have 2 minus y, and like I said, I don't like their answer, but that's fine. 2 minus y over 1, if you want to write it, equals 1 over e to the x plus 2 minus 3/4. I don't like it, but that's fine. So 2 minus y over 1, I can just delete that minus 1 there, right? Anything divided by 1 is itself. How do I move the 2? Subtract. Yeah, just subtract it. Negative y equals 1 over e to the x plus 2 minus 3/4 minus 2. Last move. How do I remove that negative in front of the y? Multiply both by negative. So look what they have. Y equals, I'm going to turn that negative 2 into a positive, 2 minus that fraction. 1 over e to the x plus 2 minus 3/4. And there it is. I don't like it. I think it's nasty. But that's how they did it. I was tempted, in case you're wondering what I was tempted to do, I was tempted to do this. Minus 1, I was tempted to go 4 over 4 like this and make one nice little fraction. 4 e to the x plus 2 minus 3 all over 4. Do you guys see what I wanted to do? But I didn't do that. All right, is that the last one that I said we were going to do? Yes. All right, guys, log into Delta, practice. You just need to practice now.